Very good morning, students. So let us continue the chapter interpolation and extrapolation by solving few more problems from binomial expansion method. In the previous video, I have clearly given you the basic problems how to calculate from the binomial expansion, right, and how to estimate the missing terms, whether it is interpolated as well as extrapolated value, right. Both the things I have clearly shown in the previous video. Now let us continue few more problems from the binomial expansion method, and later on I'll be explaining about the Newton's advancing difference method. Clear, guys? Here we go. Interpolation and extrapolation. The next problem. Interpolate and extrapolate. Interpolate and extrapolate the missing values in the following data. The missing values in the following data. Look at here the table. X 5, 10, 15, 20, 25, 30. Next, Y values. 5, 8, missing, 13, 15, missing value. Now, solution. Clearly you just see whether the binomial expansion method conditions are being satisfied or not. We have to look into it. There must be a common difference among independent variables x, right? 5, 10, 15, 20, 25, 30. Yes, there is a common difference. Next, the missing values are clearly shown, right? And the missing value must be the one of the value of x. Condition number 2. That is also satisfied. And another thing is no consecutive missings. So all the three conditions are being satisfied. Therefore, see here, anywhere did they mention is it from binomial expansion or Newton's method? No, it never. Clear? So depending upon the data, by following those conditions, which method is suitable, that has to be applied. So all the three conditions are being satisfied. Now let us see the solutions. First and foremost, we need to count how many known values. 1, 2, 3, 4. There are 4 known values. Therefore, write down here the known values are 4. That is n equals to 4. Now, at n equals to 4, what is a Pascal's triangle, guys? 1, 4, 6, 4, 1. At n equals to 4, the Pascal's triangle line is 1, 4, 6, 4, 1. y4, y3, y2, y1, y0. Before that, you just make entries here. y0, y1, y2, y3, y4, y5. First and foremost, we need to estimate the interpolating value and then later on extrapolating value. Now, substitute here plus minus equated to 0. This is how you need to expand the form, which is y minus 1 whole power of 4 equals to 0. This is what we have expanded. Clear, guys? Right? So we have to expand this. Now substitute the values. 1 into y4 value is 15 minus 4 into y3 is 13 plus 6 into y2 remains same minus 4 into 8 plus 1 into 5 equated to 0. Simplify this now. 15 minus 13 fours are 52 plus 6y2 minus 8 fours are 32 plus 5 equated to 0. That is, what's the answer? 6y2, 15 plus positives you add. 15 plus 5, 20. 20 minus 52, minus 32. Minus 32, minus 32, how much? Minus 32, minus 32, minus 64. Therefore, 6y2 equals to, send the 64 to the other side. 64, y2 equals to 64 by 6. So, what's the value? 10s are 10.6666 you will be getting it. So, approximately 10.67. So, the missing value here is 10.67. Now, let us consider this as equation number 1. As I have explained earlier, from equation 1, there are two ways you need to be calculated. I mean, you need to be not like both the things you have to do. Any one you can choose depending upon your convenience. Am I clear? See, now the missing value, interpolated value has been found. How many known values were there after estimating the missing term? 1, 2, 3, 4, 5. 5 known values were there. You can calculate just by putting. Now, the number of known values were 5 and you can estimate y5 by using 5th Pascal's triangle. That is one way of calculating. Another simplest way I have explained you that from the equation 1, just the suffix has to be increased by 1 to the entries. I mean y4, y3, y2, y1, y0 you have made, right? In the equation number 1. Now, here the suffix has to be increased by 1. Suffix has to be increased by 1 means just write from 1 suffixes are being increased by 1. That is 1 into y5 minus 4 into y4 plus 6 into y3 minus 4 into y2 plus 1 into y1. So from the same equation, the suffix we have increased by 1. Take it as equation number 2. Now substitute 1 into y5 remaining minus 4 into y4 is 15 plus 6 into y3 is 13 minus 4 into y2 is 10.67 plus 1 into y1 is 8. Now simplify this one. y5 minus 15 fours are how much? 60 minus 60 plus 13 6 are how much? 6 times are 60, 80, 78 minus 4 into 10.67. 4 into 10.67 is 42.68 plus 8 equated to 0. Therefore, y5 minus 16.67. After simplifying all this, minus 16.67 you will be getting. Therefore, y5 value is 16.67. Here y3 is, here y2 is 10.67. Just have a look, guys. So this is how we need to calculate the problem. Is it clear? Just have a look once again. Is it clear, guys? Just one more problem we are going to solve now. Let us see. Look at the next problem. Exercise question number 14. Interpolate the business in 1982 and extrapolate for the year 1984 from the following data. So years are given and business in lakhs they have given. So here two missing values were 82 year and 84 year. Those two we are going to calculate now. One is interpolating and another one is extrapolating value. See, how many known values? 1, 2, 3, 4, 5. There are 5 known values. Here known values were 5. That is n equals to 5. Now, at n equals to 5, what is the Pascal's triangle? 1, 5, 10, 10, 5, 1 equated to 0. Then y5, y4, y3, y2, y1, y0. Plus minus, plus minus, plus minus. This is the expansion. Take it as equation number 1. Now here make entries. This is y0, this is y1, y2, y3, y4, y5, y6. First and foremost, we need to calculate the interpolating value, which is 82 year. Substitute the values now here. 1 into y5 is 780 minus 5 into y4 need to be estimated plus 10 into 365 minus 10 into 235 plus 5 into 150 minus 1 into 80 equated to 0. That is 780 minus 5y4 plus 365 into 10 is 3650 minus 2350 plus 15 5s are how much? 15 5s are 75. 750 minus 80 equated to 0. Now calculate, now simplify that. 780 plus 3650 minus 2350 plus 750 minus 80 equated to 2750 minus 5y4 plus 2750 equated to 0. Therefore y4 equals to 2750 divided by 5. 2750 divided by 5, how much? 550. Interpolating the value, what it is now? 550. We have interpolated the missing term 550. Similar procedure. From equation 1, suffix has to be increased by 1 value. Similarly, you write down from 1, suffix has to be increased. 1 into y6 minus 5 into y5 plus 10 into y4 minus 10 into y3 plus 5 into y2 minus 1 into y1 equal to 0. So you are not supposed to change the line. Only you are supposed to change the suffix of the entries. Right? Now substitute 1 into y6 minus 5 into what is y5 value? 780 minus 5 into y5 is once again 5 into y4, 10 into y4. What is y4 value? 550 minus 10 into y3 is 365 plus 5 into what is y2? 235 minus 1 into y1 is 150 equated to 0. So y6 minus, simplify this one, 780 into 5. 780 into 5 is 3900 minus 5500 minus 3650 plus 5 into 235. How much? 1175 minus 150 equated to 0. Therefore, y6, simplify that one guys. Minus 3900 minus 5500 minus 3650. This is plus. Minus 3900 plus 5500 minus 3650 plus 1175 minus 150. You'll be getting minus 1025. Therefore, y6 equals to 1025. Here the value is 1025. This is how the extrapolating value need to be calculated. Are you clear guys? See here, one important assumption need to be followed every time. What it is? There must be a sort of uniformity in the dependent variable y. Look at here, 80, 150, 235, 365, 550, 780, 1025. Uniformity in the sense it must be a rising or it must be a falling, right? So it is in a rising, increasing direction. Am I clear? So that is one of the important assumption in binomial expansion as well as in the new interpolation and extrapolation. Important assumption it is. There must be a sort of uniformity after estimating, after analyzing the missing terms, whether it is interpolated or extrapolated or both. There should be a uniform manner. Am I clear? Either increasing or decreasing kind of manner it should be. Is it clear guys? Right. Now one more problem I would like to explain, and then later on in the next video I'll start freshly with Newton's advancing difference method. Right, due to shortage of time in this video I would like to give you one more problem, and then later on in the fresh coming video, in the next video I would like to start with the complete Newton's advancing difference method, explanation to problems, everything. With this video we will wind up binomial expansion method till the end, right? Till the last concept of binomial expansion method we shall finish in this video. In the next video onwards we shall start with Newton's advancing difference method. Am I clear? Let us see one more problem from binomial expansion method, and we will wind up the concept from interpolation and extrapolation, the binomial expansion method. Let's see that. Okay guys, let us see the last problem from binomial expansion method. Interpolate and extrapolate the production for the years 2000 and 2010 from the data given below. Years 1980, 85, 1995, 2000, 2005, 2010. Definitely there is a common difference, right? Next, the missing values were given under 2000 and under 2010. So both the missing values were being clearly given as one of the value in independent variable x. So second condition is also been satisfied. Let us start. First make entries y0, y1, y2, y3, y4, y5, y6. So the known values were n equals to 5. So y minus 1 whole power 5 you need to expand. That is at n equals to 5, Pascal's triangle 1, 5, 10, 10, 5, 1. So y5, y4, y3, y2, y1, y0, plus minus, plus minus, plus minus, equated to 0. Take it as equation number 1. Just simply substitute 1 into y5, 40, minus 5 into y4 need to be estimated, interpolated. 10 into y3 is 26, minus 10 into y2 is 19, plus 5 into y1 is 12, minus 1 into 5, equated to 0. So 40 minus 5y4 plus 260 minus 190 plus 60 minus 5, equated to 0. So 40 plus 260, 300, 300 minus 190, 110, 110 plus 60, 170, 170 minus 5, 165. Y4 equals to 165 by 5. How much? 3s are 33 5s. The missing value is now 33. We have estimated. Now increase from 1. Suffix are to be increased. 1 into y6 minus 5 into y5 plus 10 into y4 minus 10 into y3 plus 5 into y2 minus 1 into y1 equal to 0. So y6 minus 5 into, what is y5 value? 40 minus 10 into y4 is 33, which we have estimated just now, minus 10 into y3 is 26 plus 5 into y2 is 19 minus 1 into y1 is 12. Therefore y6 minus 5 4s are 20, 200 plus 1033 is 330 minus 260 plus 19 5s are how much? 5 10s are 50, 5 9s are 45, 95 minus 12 equal to 0. Simplify this now. Y6 minus 200 plus 330 minus 260 plus 95 minus 12. How much it is? Minus 47 equal to 0. Therefore y6 value is 47. The next missing value is 47, extrapolating value. Am I clear, guys? See, there is a sort of uniformity, increasing order. This is how the binomial expansion method, estimating the values within and outside, interpolating as well as extrapolating. This is how we need to calculate. This is how we have to calculate using binomial expansion method. Are you clear, guys? So this expansion clearly from the Pascal's triangle, which has been learnt in PU1 already, right? You know very well. Just only the second thing, when we want to estimate the extrapolating value at a time, right? After solving the interpolating only, we can able to solve extrapolating value in two ways. I said you, one is after estimating this one, again one known value, you will be increasing it. Here we have taken 5. After estimating this, it will become 6. 6 known values, take the 6th Pascal's triangle, same answer you will be getting it once again. But there is a simplest method. Rather than putting one more Pascal's triangle line by increasing the number of known values, increase the suffix from equation 1, right? Suffix has to be increased. This y5 should be increased by 1, y6. This y4 should be increased by 1, y5. This y3 increased by 1, y4. y2 increased by 1, y3. This increased by 1, y2. This increased by 1, y1. That's it. So from equation 1, just suffix is to be increased by 1, then definitely you will be getting the extrapolating value, rather than increasing the number of known values and again estimating the missing term of extrapolating value. Just from the equation 1, suffix has to be increased and substitute the values, you will be getting the answer. Am I clear, guys? This is how the binomial expansion method is to be calculated. Hope you followed it and understood clearly. In the next video, I am not going to explain once again these binomial expansions method. Remember, straight away I am going to discuss about Newton's advancing difference method, which needs maximum time and very cautious while calculation. Clear? So that is very important method which you need to learn thoroughly, because this you have already come across in your PU1. Only the thing is, in the extrapolating value at a stretch, how to calculate that again, that only thing you have learnt in PO2. Everything is known procedure, but Newton's method is completely new to you, right? It is very new concept. It needs time to give the explanation, as well as it needs time to understand the concept also. So we will spend maximum time in Newton's method, and maximum videos will make in Newton's method. Am I clear? So hope you understand the binomial expansion method. We shall wind up here now. Please watch all the videos, guys, so don't waste your time, and request you that please attend MyPal live class and clarify your doubts. Then only we are able to understand that you are understanding the concept. Is it clear? So with this, I just put a dot for it. Let us meet in the next video with Newton's advancing difference method. Stay home, stay safe. Thank you. Have a nice day.